just see their examples. Hamilton method. Apportioning 12 seats among 4 regions with populations of 60,000, 40,000, 50,000, and 30,000 respectively. So we have our population here. Firstly, we need to get our SD, or the standard divisor. So how do we get it? Again, we get it when we total the population, 180,000, and divide it to the given here. So 180,000 divided by 12 is equals to 15,000. So our standard divisor is 15,000. To get the quotient, we divide our population to the SD, which is 15,000. So 60,000 divided by 15,000 is 4. 40 divided by 15,000 is 2.67. 50K divided by 15,000 is 33.33. And 30,000 divided by 15 is 2. Next, to get the standard quota, we just need to get their whole number here and transfer. So 4232. So as we can see, that's why we call the standard quota as a partial apportionment, because we still need to find partial apportionment, which is here. So 4 plus 2 plus 3 plus 2 equals 11. So in our partial apportionment, we just need to find the highest number here. So we have 4 as our highest here. So 4, we add 1 to 4. So 4 plus 1 equals to 5. So since we only need to find one more addition to get the 12 seats we only need this one. So 5 plus 2 equals 7. 7 plus 3 equals 10. 10 plus 2 equals 12. So we have 12 here as a answer. So now let's have Jefferson plan. Apportioning 10 seats among 3 populations of 50,000, 80,000, and 70,000 respectively. So we add our population to get our SD. So add this was 200,000 divided into 10, which is given here. So if we solve this using our SD, if we solve our quotient using our SD, we won't get the final apportionment how much harder we try. So in here, we use the MSD, or the modified standard divisor. So how do we get the modified standard divisor? We get it by trials and errors. So after calculating multiple times, I found out that we can use 18K as our MSD here. So 50,000 divided by 18,000 equals 2.78. 80,000 divided by 18,000 equals to 4. And 70,000 divided by 18,000 is 1.33. So same method as the Hamilton. We just copy the whole number here to get our standard quota. So in our final apportionment here, since 4 is our highest number, we'll just add 1 to 4, so it will become 5 here. So 2 plus 5 equals 7. 7 plus 3 equals 10. So here we have our final apportionment, which is 10. Next example is the Webster's method. Apportioning 8 seats among 3 regions with populations of 10,000, 150,000, 150,000 and 50,000 respectively. So add up our population here, which is in total with 300,000 divided by 8, which is the given here. So 300,000 divided by 8, our SD or standard divisor is 37,500. So unlike Jefferson, we don't need to use modified standard division here, because it will automatically total the apportionment given. So 100,000 divided by 37,500 is 2.67. 150,000 divided by 37,500 is 4. 50,000 divided by 37,500 is 1.33. So if we round them up, round them off, we have here 2.67. That will become 3. 4 will remain as 4, and 1.33 will remain as 1. So 3 plus 4 equals 7, plus 1 equals 8. So we have our apportionment here. Now, using the previous example, let's calculate it using the Huntington-Hill method. So, same process. Add them all up to get the standard divisor, which is 700 divided by 40 equals 17.5. So, if in Jefferson method, the MSD should be lower than the standard divisor, in Huntington-Hill method, take note that the MSD should be higher than the standard divisor. So, so divide the population to the MSD to get the standard quota. 120 divided by 17.42 is equals to 6.88, and so on. So, as you can see, we have lower, upper, geometric mean, and rounded sections here. So I'll explain to you how can we get this So in getting the lower quota here, we just have to copy the whole numbers from the standard quota. So 6.88 to 6, 5, 7, 4, 11, and 4. In terms of upper quota, we need to add 1 on each lower quotas. So 6 plus 1 equals 7, 5 plus 1 6, 7 plus 1 equals 8, 4 plus 1 equals 5, 11 plus 1 equals 12, and 4 plus 1 equals 5. So to get the geometric mean, we need to multiply the lower and the upper quotas. So the product of upper and lower quotas we should get its square root. So 6 times 7 equals 42. So get the square root of 42, which is the 6.48. And 5 times 6 equals 30. So square root of 30 is 5.47, and so on. So in this rounded, the rounded section here, we use the rule that it uses the rule that if the standard quota is less than the geometric mean, we should round down. Hence, if the standard quota is greater than or equal to the geometric mean, we should round up. So let us check. Standard quota here is 6.88. Compare it to the geometric mean, which is 6.48. So, as you can see, our standard quota here is much higher. So, we should round up. So, our rounded product here is 7. Same process, 5.16, compared to the geometric mean, which is 5.47. So, we can see that geometric mean is greater than the SQ, and SQ is less than the geometric mean. So, 5 will remain as 5. Same process as the others. So, after getting all the rounded data, we should sum it up to get our final allocation. So 7 plus 5 equals 12. 12 plus 8 equals 20. 20 plus 12 equals 32. 32 plus 8 equals 40. So we have our 40 here. Before we proceed to our next topic, I want to apologize for my raspy voice because I got a cold yesterday. So I'm gonna put a caption instead so you can understand what I'm saying here. So now, let's talk about flaws of apportionment. Of course, apportionment without its flaws is not real. Apportionment has 4 paradoxes, which are the quota rule, Alabama paradox, population paradox, and new states paradox. Now let's talk about the quota rule. The quota is the exact number of seats or resources a region should receive based on its population or other allocation criteria. This quota has three types, which is the exact quota, the lower quota, and the upper quota. Exact quota is the precise number of seats a region should get if the seats were allocated perfectly based on population. The lower quota is the greatest integer less than or equal to the exact quota. Upper quota is the smallest integer greater than or equal to the exact quota. Alabama paradox. Alabama paradox occurs when increasing the total number of seats available results in a region losing a seat it previously had. It highlights a flaw in some apportionment methods where increasing the total number of seats can lead to a reduction in representation for some regions, contrary to expectations. Next, we have the population paradox. This occurs when a region's share of the population increases, but its number of seats decreases due to the apportionment method used. It underscores the limitation of apportionment methods in accurately reflecting population changes, leading to possible misrepresentation. Next is the new states paradox. It occurs when adding a new state to a legislative body causes existing states to lose representation or seats, even though the total number of seats is increased. It also occurs when adding a new state to a legislative body causes existing seats to lose representation or seats, even though the total number of seats is increased. So, to summarize all of this, quota rule provides a benchmark for fair distribution, but also requires careful rounding and adjustments. The Alabama paradox, however, it demonstrates that increasing the total number of seats does not always benefit all the region and can lead losses for some. In the population paradox, it shows that changes in population do not always translate into proportional changes in representation. New states paradox highlights the complexities involved when adding new entities to a system, which can inadvertently affect existing entities. I hope you learned something from this flaw of apportionment. Now, let's talk about voting. Voting has four main types. These are the plurality method, the plurality with elimination, the board account method, and lastly, the pairwise comparison voting method. Plurality method, also known as the first past the post, is a voting system in which each voter casts a single vote for their preferred candidate. The candidate who receives the most votes wins the elections. This method does not require a candidate to achieve a majority. If more than 50% of the voters votes him, he'll win the election or whatever. Next is plurality with elimination, also known as the instant runoff voting or the RIV. Is a ranked voting system where voters rank candidates in order of their preferences. If no candidate receives a majority of more than 50% of the first choice votes, the candidate with the fewest votes is eliminated. Votes for the eliminated candidate are redistributed to the remaining candidates based on the voters' next preferences. This process continues until one candidate achieves a majority. Next is the board account method. It is a voting system where voters rank candidates in order for their preference. Points are assigned based on the ranking. For example, in a 3-candidate race, a first place ranking might receive 2 points. Second place receives 1 point, and third place will receive a 0 point. The candidate with the highest total number of points wins the election. Last is the pairwise comparison. It involves comparing each candidate head-to-head with every other candidate. In each comparison, voters decide which of the 2 candidates is preferred. The candidate who wins the most head-to-head matchups is declared as the overall winner. This method often employs criteria like the Condorcet criterion, where the winning candidate must defeat every other candidate in pairwise comparisons. So, example, we have candidate A, B, C, D. We'll first head-to-head match A and B, and if whoever wins the match will be a match to C, and so on and so forth. So that's how they determine the winner. So to summarize it, in the plurality method, the candidates with the most votes win. In the plurality with elimination or the RIV, candidates are ranked. The least popular candidates are eliminated in rounds, with votes redistributed until a majority is achieved. For board account method, candidates are ranked, points are awarded based on ranking positions, and the candidate with the highest total points wins. The pairwise comparison voting, candidates are compared head to head, and the candidate who wins the most pairwise comparison wins.